In this video, we're going to look at one-step inequalities. We want to answer two questions. First, what do the inequality symbols represent? And second, how can I solve one-step inequalities? Remember, at any point in the video, you can pause it and go back if you need to reference something again. So let's look at this visual picture of an inequality. When we look at an equation, this seesaw is balanced, which means that the weight on either side of the seesaw is equal. Well, in an inequality, we are looking at something that is not equal. And in this image, we can see that the x is lower to the ground the 8 is lower to the ground and the x is higher. And just like a seesaw in real life, the heavier weight is going to be pulled down to the ground and the lighter side is going to go up in the air. So we can see that 8 here is going to be greater than x. And unlike an equation, an inequality actually has more than one solution. So in this picture, we could say that x is going to be less than 8. So x could be 5. 5 is less than 8. It could be -2. -2 is less than 8. It could be 3.5. 3.5 is less than 8. So we can see that an inequality is going to have multiple solutions, and we're going to show that a little bit differently than we would with an equation. So what do the inequality symbols represent? So we have 4 different symbols. We have x is less than 4. And then right below that, we have x is less than or equal to 4. And that little line underneath the less than symbol makes that less than or equal to. And then on the right, we have x is greater than 4. And we have x is greater than or equal to 4. And all of those symbols can be represented with a graph. And I'm going to show you how to represent that on the number line. The number line and the graph will represent the entire solution set. So just like with equations, there is one solution. In an inequality, there's a solution set because there's more than one solution. So I have here x is less than 4. So I'm just going to label 4 somewhere on the number line. Then I'm going to put a big open circle around it to represent where 4 is. And then I'm going to take my arrow, my graph, and I'm going to graph everything less than 4. If you want, you could label all the other pieces, all the other values on the inequality graph, but you don't have to. And that open circle where the 4 is represents that it's just less than and that it's not equal to 4. So when I come down here and I want to do less than or equal to 4, I'm going to do the same thing. I'm going to find 4. I'm going to make a large circle there. And then this time it's going to be shaded, or we call that a closed circle. And that shows that it can be 4. And then I'm going to shade everything to the left. And one trick that I find very helpful when graphing is that if your variable is on the left side, so here we have x and then we have less than or equal to 4, then the arrow is going to go in that direction. So let's look at this next one. We have x is greater than 4. So I'm going to find 4. It is just right here, it's just a greater than symbol. So I'm going to put an open circle at 4. And then as we can see, that greater than is going to tell us it's going to be over here on the right. And we can put an arrow there. Then we have x is greater than or equal to 4. So in that case, I want to enclose that 4 to show it can be 4. And then I'm going to show everything greater than 4. Okay, so let's look at how we are going to go about solving these. So just like solving equations, we're going to isolate the variable by using inverse operations. And just as a quick reminder, the inverse of addition to undo addition is subtracting. The inverse of multiplying to undo that is division. And then we want to keep the inequality true by doing the same thing to each side. And then the last thing is a special case in which we are going to flip the sign if you multiply or divide by a negative. And I'll show you that in another example. So let's look at our example. We have x minus 15 is greater than or equal to 18. So just like equations, we're going to isolate x. What we do to one side, we're going to do to the other. I have x is greater than or equal to, and then 18 plus 15 is going to give me 33. So I'm going to show you how to check it. When we're looking at inequalities, we always want the inequality to be a true statement. So we're going to check that by picking a value. X is greater than or equal to 33. So I'm going to pick something that is greater than or equal to, and I'll pick 35. And then we're going to plug that back in to our original inequality statement. So if I have 35 minus 15, that gives me 20. And then I'm going to read that statement and decide if it's true. 20 is greater than or equal to 18. And that is a true statement. So I know I've solved correctly. So I can go ahead and come down here, graph 33. If it helps, you can go ahead and show other values on the number line. Okay, I'm going to find 33. I'm going to draw a circle. It is greater than or equal, so I'm going to close that circle in, and then I can shade the values to the right. Okay, great job. We did one example. Let's look at a few more. We want to find the value of x needed to make the inequality true. So here we have negative 4x is less than 20. So remember I said we are going to flip the sign. I'm going to show you why here. So let's go ahead over here and look. Negative 4x is less than 20. Let's go ahead and solve like we normally would. So first we want to isolate the variable where it's saying negative 4 times x. So we're going to divide by negative 4 on both sides. And let's pretend like we don't flip the variable. So we're going to have flip the inequality. X is less than 20 divided by negative 4 is going to be negative 5. Well, remember I told you we could check it. So let's go back and check it. Let's pick a number. X is less than negative 5. Let's pick a number less than negative 5. And I'll go ahead and pick the number negative 10. So if I go here, I have negative 4 times negative 10 less than 20. So negative 4 times negative 10 is going to give me a positive 40 is less than 20. And I know, well, that's not correct. That does not make a true statement. So now let's look by what we should do, which is to flip the inequality, and I'll show you how. So we're going to do the exact same steps. We have x, then we're going to change this inequality statement. Instead of saying x is less than 20, we're going to change that to greater than, and then we're going to do our math here, 20 divided by negative 4, which gives me negative 5. Now when I go to check that, let me pick something x is greater than negative 5, so I'm going to pick 1. So I have negative 4 times 1 is less than 20. That gives me negative 4 is less than 20, which is a true statement. So I can go back to my graph, put my negative 5. It's greater than, and it's not close, it's not equal to. So I'm going to leave it at open circle, and I'm going to shade everything greater than negative 5. And here would be 0, so I can be confident that that's correct. Okay, let's look at another one. We want to find the value of f needed to make the inequality true. So we have f divided by 15. We want to undo division by multiplying both sides by 15. We're going to have f is greater than or equal to negative 1 times 15, which is going to be negative 15. So I can go ahead and mark that. It's greater than or equal to, and so it's going to go to the right. And remember in this, that 15 that we multiplied by was a positive. So that's why we didn't change this symbol here. Whereas in the other one, before it, we were dividing by a -4. So had that been a -15 that we were multiplying by, then we would have flipped our inequality statement. Okay, let's look at this one below. Solve the inequality below. -30 is greater than g minus 15. So you might notice that our variable, our letter g, is on the right side of that inequality symbol. We're going to still do the same thing. We're going to isolate g by itself. We're going to see that, and then we're going to have -30 plus 15, which is going to be -15. Is greater than g. Now that's a little bit tricky to read and think about, so I always like to rewrite that to where the variable is on the left. G, and I'm going to basically look at it backwards. G is less than -15. And this helps me when I graph it because now the inequality symbol is pointing in the direction in which I'm going to graph. Now again, this right here, it is correct. I just personally think saying g is less than -15 is easier to understand and easier to graph, but they are both correct answers. Okay, let's look at a word problem. Abigail needs to make at least $199 to purchase the new phone that she wants. Last week, she babysat and earned $45. Write and solve an inequality to find M, the amount of money Abigail needs to meet her goal. Okay, so I always look at what it says. She needs at least $199. And if you think about just real life, if you needed at least a certain amount in order to buy something, that means you need $199. You could have 200, that would be good. But if you had 198, that wouldn't be enough. So we can say that whatever she needs has to be greater than or equal to $199 or she won't be able to purchase it. It also says that she babysat, she has $45, and we want to find out how much more she needs. So we can say whatever she needs, it told me to use M. So whatever she needs, M, the amount of money, plus the $45 she already has to be greater than or equal to $199. So now we can solve that by isolating our variable. We have M is greater than or equal to, and when I do that math, I get $154. So Abigail needs to have $154 or more than that in order to buy her phone. And then lastly, it says that Wendell wants to have more than $45 before he goes shopping at the mall. If Wendell does his weekly chores, his parents give him $7.50. Write and solve an inequality to find C, the number of times Wendell should complete his weekly chores in order to have the amount he wants for the mall. So he wants, again, where it's always helpful to go back, wants more than $45. So in this case, here's my 45. He wants more than that. Would 44 be enough? No. Would 46 work? Yes. Would 45 work? Is 45 more than 45? Well, no. So I'm going to have to write it like this with just the greater than symbol. Then we know that his parents will pay him $7.50 every time he does his chores. So we can represent that as $7.50 times the number of chores, his weekly chores. And that we want that value to be greater than 45. So we're going to undo multiplication by dividing. And we will get that C is greater than 6. So he has to do his chores more than 6 times. And I'll go ahead and write that out. Because if he does it just 6 times, that's not going to be correct. So he could do it 7, 8, 9, 10. Any of those options would work. Okay, well, we did it. We talked about what the inequality symbols represent and how to go about solving those. Great job. Thanks for learning alongside me.